Welcome back. And this lecture is the G30 International Program in Nagoya University. Additional lecture. And from the last lecture, we have discussed the inverter. Before the last lecture, we have discussed from the 1 to 9. That discussion is the DC-DC converter. And from 10, today's lecture is 11, but from 10 we will discuss the inverter. So in the last lecture we have discussed what is inverter, so that we will understand the essence of the inverter. Today we will discuss about the single phase inverter. Single phase inverter means for the output power line we can obtain the AC current. AC current is alternating plus and minus, so that we can obtain for example, this one is the alternating AC current, plus minus. In the repeatedly, alternately moved. That is the AC. This is the direct one. This was all direct one. However, the alternating current means this one. All the AC. That is all the AC. Single phase. Today's theme is the single phase inverter. Single phase inverter means we can obtain in the load current is obtain the alternating current. And upper figure is single phase inverter. Lower figure is the single phase inverter. What is the difference? Power semiconductor is increased 2 times. The same voltage, the same DC line voltage. Additional power semiconductor is required. Usually, each power semiconductor means that sync power semiconductor module or 2-in-1 module. 2-in-1 module means this power line. 2-in-1. That one. Or 3 connected to that one. So this means the higher cost as compared with the upper one. However, usually we will use this one for solar power PV applications, or some many for the automotive area. For that means the battery charger connected to the power line, and we can obtain the bidirectional power control using this converter. For example, the very famous application is PV. PV is the PV solar panel. PV, but we can only obtain the DC line, so the boost chopper, and connected to the battery, storage battery, and single phase inverter is inserted in this line, and this one is the AC line and the power line to the constant line is worldwide AC right, AC line. So we can power connected to the energy storage and output, and sometimes it input and storage. And this one, in this part, in this element, we will apply to this type of inverter, not this type. Why? Today's discussion is here. Okay. Okay. First of all, let's discuss to the usual. Please check to the each voltage. Voltage means the here is the VA. How they call it? We discuss the VA, VB, and VAB. Please describe the illustrate the each voltage waveform. Okay. Do you understand the VA and VB? VA means usually VA means from the ground line to the VA means this is the VA. Okay. However, this line to the this one, from this line to this line, is that means the VA. So we can look to the this line is the VA. It's okay. This is our last lecture discussion. Already we have illustrated that VA. Okay. Please check to the last lecture's movie. And today we regard the VA and VB for obtaining the VAB. This is the VAB because the same discussion from this ground line point to this output line point. This line is the VA. Okay, and this terminal, right, from ground line to this terminal voltage, that means the VB. VAB is VAB. Or VAB means the vector VA minus VB. Of course, you can use this one. Okay, very easy. And we have explained the phase S condition, switching condition. That means phase B's switching condition. This means, and one means already we have discussed. One means upper switch on. Zero means the lower switch on. Switch on. Okay. In case of the lower switch on and zero, upper switch is all, of course, all are off. Upper switch on, lower switch is off, of course. Okay, you can, using the knowledge, you can describe the VAB. Our target is the VAB. Okay, and if you can, please describe load current IAB. Let's start. I will wait to the training, karate training. Please wait. This is a famous karate's weapon. That name is Sai. Attack. Okay. With the above switch on, and we can look to this line is this voltage. So please describe. And 0, in case of 0, okay. 1 means 100 volt. 0 means minus 100. Okay. So okay. In the last lecture, we have already discussed, so that I have skipped to the explanation.よっしゃ。Okay. Please obtain the VAB. Please discuss. The karate's attack, very important to the holding. This training is the hold to the hand. So if without this weapon, we can attack the same time. The weight on this hand. Okay. This is a karate's essence. Okay. If it's difficult, please use this theory. VA minus VB, VA minus VB minus 100 in this term. Go. Oh, 200. So 200 200。ここはマイナスからマイナス100からマイナス100からマイナスのマイナス100だから0。今度はマイナス100からプラス100だからマイナス100マイナス200。0。Important point is that this value is at 200 or minus 200. Okay? This is answer. And current IAB's starting point, if starting point is here, the plus, plus means the transient phenomena, using the transient phenomena, and increase value, the curve, in case of the increased value, the, the waveform is here, down here, okay? Remember? So, increase, of course, the in case, from the load, plus voltage, that means the current will increase. So the current is increased because the 200 very high voltage is across to the load. So increase, okay? And however, the that output voltage is zero. That means the low, これは lower switch is on. 00 means the lower switch is on. So current is flow through the plus voltage, plus current flows through on, and this one is on. So using the diode, the current flows through. Flowing current, this loop. However, there is a resistance in the experimental setup. So the idea, in case of the idea, there is only the inductor. There is the value is equal. However, there is resistance. So that in case of the transient phenomenon, there is decrease because of the loss for the in heat. So in heat energy rules this load only. Okay, and in this point, because of the lower voltage is across to the load, so current is here, and 1 means the flow through this loop, so the it's pop, 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 pop. In case of the load, we can obtain the AC current, alternating current, plus side, minus side, plus side, minus side. This we can obtain the IAB. That means the IAB. IAB means the alternate current. So we can obtain the AC current. So we call this is the inverter from the DC power line. However, in case of a load, we can obtain the AC current. So this one operate for the inverter. We call this one inverter. However, we can obtain the AC current too. Which is better? As you know, in case of the power electronics area, voltage value is very important because the voltage value, that means that sometimes That means the battery. Battery is very expensive. This type of single-phase inverter, we can obtain the output voltage is only to the 100 volt, peak to peak is only the 100 volt. However, using the 2 times number of power semiconductor, we can obtain the 2 times value of the voltage, 200. Peak to peak mean the 200 voltage. In many power electronics applications, of course, the automotive area, DC voltage, that means the battery. Battery is very expensive. Usually the Tesla's Model 3s, Tesla Model 3, Model 3. Do you know the Model 3? In Japan, ドルでなんぼって言うんだろうこのぐらいするのね。I guess Japanese and thousand. これぐらいするの。これ円。So in case the dollar is this value, but in Japanese yen, 5,000 over. Very expensive. However, the battery value around どのぐらいかな。This is battery value. Cost of the battery. Expensive. Mainly the battery cost. So battery is important. And our application side, we like to use this battery very effectively. Using the 200 voltage, however, we can obtain only the 100 voltage. However, 200 voltage battery, we can obtain the 200 voltage peak to peak AC line, AC voltage. We can use effectively of the battery voltage. So we will use this one because the expensive battery value is very important because of that cost. So we must use effectively this value. So we will use this type of inverter. That is a single phase inverter's essence. Okay? In the next lecture, we will discuss the three-phase inverter. Three-phase inverter means the three-phase current. We will obtain three-phase current. However, one phase for the effectively, if one-phase inverter, we use the 4 power semiconductor devices. Using this theory, in case of the three-phase inverter, we must use 3 times 12 power semiconductor is required in this cell, using this cell. However, we can only the 6 power semiconductor devices in the 3-phase inverter. Why? That is the next lecture essence. Okay, let's discuss the next lecture. お疲れ様です。Thank you very much.